Yeah, thank you guys. I'm very glad to be invited here. AI for Good. This is actually why we initiated the Milvus project. By creating the new infrastructure software for AI, we believe we make AI technologies more accessible to every people so that everyone can utilize AI technologies to empower themselves. I think we are helping to improving the equality of the technology. So today I will give you an overview of our open source project Milvus, its origins, current progress, and the state of our community. So here is the topic of my speech today. Milvus build up the unstructured data service. So guys who are familiar with the technology should have heard RDS, Relational Data Service. So this is for traditional structured data. So today we are talking about the emerging unstructured data service. So first, just a brief introduction of myself. I'm Drengu Zilis partner, technical evangelist. I'm also a voting member of the technical advisory committee at the Linux AI Foundation. So before joining Zilis, I worked for ICBC, IBM, Morgan Stanley, and Huawei. So most time I work with as a database engineer. In these recent 2 years, I turned to act as a database product manager. So who is Zilis? Zilis actually is the abbreviation for zillion of zillions. So you could tell know by names that we are engaged in data-related technology. We are a technology startup. We focus on developing data science software based on heterogeneous computing. We drive our software business model through the open source. Our vision is to reinvent data science, which means to provide data-related technologies for the new domain, the new scenario, the new requirement, and to help people better discover the value contained in the data. So our open source project Milvus has now joined the AI Foundation as an incubation project. So Zilis is currently a major contributor to the Milvus project. So speaking about the unstructured data, so we generally divided the data into 3 categories. The first is structured data, including things like numbers, dates, strings, and so on. The second is semi-structured data, mainly includes text information with a certain format, such as various system logs. The third is so-called unstructured data, like pictures, video, voice, natural language. These are not easy to be understood by the computer. So previously we have like relational database, traditional big data technology to solve the problem of structured data. And the semi-structured data, it can be handled by a text-based search engine like Elastic or Solr. Only the unstructured data, which accounts for 80% of the total data sphere, it's just lacking in effective analytic models, methods in the past. Until the rise of AI, like deep learning technology in recent years, unstructured data processing is accelerated. The charm of deep learning model is just shown as here. It can transform the unstructured data into the embedding vectors or matrix, which can be easily handled by the computer. So the process of unstructured data is transformed into vector computation. So let's first take a look about how people usually compose their AI applications. So as shown here, flow-based AI application is a very typical example. Assuming we are going to analyze a video, we can create some operation streams, usually called pipelines. For example, the leftmost pipeline, it captures the video frames and then extract those features from the captured images. So here, for example, we use the VGG model, a model with excellent generalization capability. At last, we got image feature vectors. So the pipeline in the middle, it handled the sound. So eventually it generates the audio vectors that are converted from the sound. And the rightmost pipeline automatically labels some attributes for the video. So if you have other special requirements, you can build up a new pipeline to do related processing. So this is why these kind of flow-based AI applications are so popular, because they are flexible. And the developer don't even have to write code. There are web-based interfaces to help users to compose the new process. If you have no idea how to start, you can also usually find some useful samples. But also in this way, it also brings us a new challenge. The data becomes very fragmented. So originally we only have one video, but with this operation of the pipelines, it was gradually transformed into different data spread in different corners. So what shall we do? Let's turn to the traditional hierarchical view. So both the top inputs and the bottom outputs are unstructured data here. The AI technologies mainly functions in the middle two layers. The green layer is the model inference, and the blue layer is the data service. So the task of model inference is to transform the unstructured data into embedding vectors. So models are pre-trained, but serving them efficiently is still not easy. The good news is there are already some mature projects in the industry, such as the NVIDIA's TensorRT, Intel's OpenVinyl, Microsoft has OnyxRT, and recently Google is also developing TensorFlow runtime, TFRT. But there is no comprehensive solution for the data service layer. So some people, they put those embedding vectors in a structured database, others in things like HDFS, and then analyze the vectors through a Spark cluster. Also, you can use AN libraries. So in this area, everyone makes their attempts. So the challenge is how to manage and analyze the embedding vectors efficiently. Although a large number of pre-trained models are now available, but AI technology is still difficult to go production because at the data service layer, the cost is still high. So in order to address this challenge, our answer is to build up the unstructured data service powered by the Milvus project. It contains 4 parts. The first part is the embedding similarity search. So it covers the vectors, both the high dense vectors for the deep learning scenarios, and also the sparse vectors for the traditional machine learning scenarios. The second part is the attributes or the Scala data. For example, a label described by the structured data like strings. So combine attributes and the vectors, we can provide the capability of kind of hybrid search or collaborative search. The third part is to support multi-models. As in previous example, a video has vectors of different dimensions. They are image vectors and audio vectors. So in the real world, the multi-model search is a pretty common requirement. So then we need to introduce the kind of concept of entity for the unstructured data. An entity could contain multi-vectors of different dimensions from different model or even from different source. The fourth part is the scoring component. So in some scenarios like multi-model search, because we introduce different models, then the fully connected layer of different model will need to be fused to form a new scoring mechanism for the analysis of this unstructured data. So at present, Milvus already has built up the vector analysis capability. We are currently developing the attributes part. It will be available in the middle of this month, middle of September. And also we are moving forward with this multimodal and scoring functionality. So eventually, Milvus is not just positioned to be a high-performance vector search engine. We want to build a comprehensive infrastructure software for the unstructured data service based on this Milvus project. So maybe you guys have been convinced that we need an unstructured data service, but there's still a question about why not build it through a traditional database or some big data technology. So a vector also looks like a number. So is there any difference between a vector and a number? So to be precise, a vector consists of a set of numbers. The difference between vector and number, I think there are two major aspects. First, the common operation of vectors and the numbers are different. For numbers, we normally do some addition, subtraction, multiplication, and division. But for vectors, the most common operation is to calculate the similarity. So you see here, I giving the formula for computing the Euclidean distance. This is one kind of very common similarity matrix in the vector analysis. And you can see the computation of vector is much higher than the normal numeric calculation. Secondly, the index organization of data is different. So between two numbers, you can compare the value. So we could create the index for these numbers based on the algorithm like B-tree. But between two vectors, because you cannot compare you cannot compare the value between two vectors. So we can only calculate the similarity between them. So the vector index is usually based on algorithm like clustering or graph-based. So these are all algorithm in this area called approximate nearest neighbor search, the ANS algorithm. So here I give these two ANS approach like clustering index and graph index. So because of these significant difference, the traditional database and the big data technology are difficult to meet the requirements of vector analysis because the algorithm they support, the scenario that they target are all different. So here is the big picture of Milvus. So I want to highlight four major parts. The first is the support of heterogeneous computing. So I mentioned at the beginning, our company is developing data science software based on heterogeneous computing platform. So we have some experience in this area. During Milvus design, we thought about how to support different computing resources so that we could accelerate such a computation intensive scenario. The heterogeneous computing resources supported in Milvus project, for example, if you're using x86 processor, we support an instruction set like SSC 4.2, AVX, AVX2, and AVX 512. So if you are using the NVIDIA GPU, we support the latest GPU devices, which is later than this Pascal microarchitecture. For ARM, we support the ARM64 platform. Also, we have some support. We have tested the Milvus project on like Huawei's quantum processor. And also we have some partner. We're trying to work together to see if we can extend Milvus to RISC-V processors. But yeah, RISC-V support this work is still in a very early stage. The second part is the data management function. So we want to provide the unstructured data service. So the function of data management is very critical, because in some scenarios, you need to handle those streaming data. And there are a lot of hundreds, maybe devices capturing all these data and push into the backend server. So you need to have like incremental indexing, dynamic sharding these data, and all these kind of data management related functions. The third part is the adoption and improvement of the AI algorithm libraries. So the capability of vector search is the fundamental function in unstructured data service. So Milvus can provide good vector search performance by adopting and improving the well-known and well-adopted AI algorithm libraries like Face and Noi. The fourth part here is the application development environment support. So to enable any AI developer to build their applications on Milvus, we provide several application development environments like Python, C++, Java, Go, and the REST HTTP interface. So the vector search is a computation intensive scenario, but it also has like no drawing. You know, this drawing, if you have a drawing operation in RDS, it will be very hard to perform in the in a distributed platform, in a distributed environment. But in vector search, all these kind of things like a map reduce process, so you can very easy to extend Milvus to spread it to different nodes to host different data shards. So although Milvus is a server more complicated than AN algorithm library, but people are very curious about the performance comparison, since performance impacts the hardware cost. So, and they want to set an expectation when they start to use Milvus. So we have run through the AN benchmarks. It is a set of well-known AN benchmark tests. Thanks to Martin, Eric, Alec for developing the benchmark. We forked it on GitHub and ran through the test on Milvus in several different public cloud environments like AWS, Azure, Arduino, and we also ran the test on our local servers. So here I only captured one chart of Milvus and Face. The benchmark tests generate a bunch of reports. So you can find the details on our website, milvus.io. So here, this example is based on the Milvus 0.8, and it's running on Ubuntu 18.04 LTS edition, and the cloud machine is from the AWS. So this is a single thread performance test. So in the latest version of Milvus, we start to do performance test on multi-thread performance test, because in the real world production scenario, I mean, people absolutely will use the multi-thread to run all these AN kind of search. Okay, so this is how we began the initiated the Milvus project. So the initial idea of this project was back in October 2018. At that time, we were involved in a project. We needed to deliver the vector search function. We tried to do it in our structured database, but it didn't fit well. So that's why we started to think about this challenge seriously. on April 2019, we released Milvus 0.1, and we tested in our first seed user and improved Milvus a lot. So when Milvus goes to 0.5, we are ready to open source it. So that's in the October of 2019. And in this year, March, we joined the Hierarchical AI as an incubation project. Today, Milvus is the most active project from the software development perspective in Hierarchical AI Foundation. Here is the current status of Milvus project. We have made near 6,000 commits and 16 release. We have almost 4K stars on GitHub now. We have a bunch of around more than 200 now community users. They are using Milvus to build up their AI applications, and some of them already put Milvus into the production environment. This is very encouraging for us because Milvus is still a young project, less than 1 year since it became open source. So, but why did people start to build their production AI application upon Milvus? I think the most attractive benefits are it's easy to use and it's fast, which means lower hardware cost. So developer could make the minimal viable product at a pretty low cost with Milvus. Now I will share some real-world use cases. The first one is an intelligent writing assistant. This application is supposed to help people to compose some kind of essay, like a year-end work summary, cover letter, or referral letter. So the software vendor, they first collects a bunch of corpus data. After cleansing this data, these data are encoded with the text CNN to extract the paragraph and the summary. Then they will be further encoded with the InfoSense model. At last, we get the vectors and they store them in Milvus. So when the end user submits the writing request, it will go through the InfoSense encoder and perform a vector search in Milvus. The search result will be further transferred to a draft so that user can make a minimal modification to that draft and they get what they want, a well-prepared essay. The second example, sorry, should skip this one. The second example is a big data company. They have collected a lot of corporate credit data, including 55 million trademark images. They want to provide their members with the function about search a company through the trademark image. So they build the image search function upon fine-tuned VGG model and Milvus. So since nobody knows how many people will become their new member, will start to subscribe their membership just for this new AI function. So development and the hosting cost is sensitive. They're very happy with the performance Milvus provided. So actually the average elapsed time for a search over 55 million images is around 20 milliseconds on the cloud server. So that's why I'm talking about people like to build their minimum viable product upon Milvus. In these previous two examples, the AI technology is not creating the core value. I would rather think they are creating the value add to make the products more attractive, to make their users feel these products are very, it feels they're very high tech with the AI technology empowered. But in this example, an efficient vector search is creating the call value. This is a pharmaceutical user. They want to perform a molecular analysis over 800 million molecules. This is this is the ever beginning step for a new drug discovery. So we first translate the molecule expression into a 1024 bits binary string data and store it in Milvus server. These kind of data you can consider it's a sparse vectors. And then the user will perform this kind of analysis, tiny molecule similarity, substructure, superstructure analysis over these 800 million molecules. So previously, the user was trying to build a Spark cluster to perform this kind of analysis. It will take around 14 seconds upon 30 million molecules. But with Milvus, we can now analyze over 800 million molecules within 1 second, actually 500 milliseconds on just one single server. So this is a huge cost improvement to the user. Now it's come to the end of my presentation. Here are the useful links for the Milvus project. If you want to explore the possibility of introducing the AI technology into your applications, please think about Milvus. It will be very helpful. We welcome people to join the Milvus community. Thank you, guys. If you have any questions.
Thank you so much, Jung, for the presentation. Now I ask my colleague Vishnu to moderate the Q&A session.
Thanks, Thomas, and thanks, Jun, for that very nice presentation. Let me ask you this question first. You know, you had this pictures, you had this figure somewhere in the slides which shows the role of Milvus in the overall flow, right? So I wanted to ask you, what is the input and what is the output of it? So if you take any of these examples, I think you had this, it is example, for example. So the vector is already input to the to Milvus in the form of a vector, or Milvus makes the vector. So this is not clear. Could you please explain what is the input and what is the output from Milvus, please?
Sure. So for example, in this scenario, the images will be first translated into the vector through this model inference service. This is outside of Milvus. It's out of Milvus. It's not within the Milvus, because the model inference component or project, there are a lot of good projects already doing this. So we are not trying to reinvent this part. So Milvus is handling the embedding vectors output from this model inference service. So within Milvus, it's all vectors. So when you perform an image search, for example, you give an image as the input. It will first be translated by the model inference into a vector, and then the vector will be searched within Milvus, and Milvus will return, like, for example, top 100 most similar vectors, and every vector has a vector ID, and you can make this kind of connection between the Milvus and for example, a S3 object storage, so which contains the actual picture. So you can build this kind of mapping. So since you have the top 100 most similar vectors ID, and you can find out their object URI, and you can get these pictures in the object storage.
Thank you. Yeah, that makes sense. And how do you create the training storage, if you will? So the object storage which has the vectors which you search. What do you call the creation of it? Is it similar to model training or is it something different? And how do I create that kind of vector database?
Yeah, we have some API for more like a SQL type database. Like user only need to create a database and start to we call it a collection, a vector collection, and you start to insert these vectors into this collection, and the Milvus will handle this index creation process. Of course, you need to specify what kind of index you want. We suppose some kind of indexes for different scenarios. So after you define this index and you start to uh, insert this data into this collection continuously, Milvus will handle all the following index creation, incremental creation stuff, and the data sharding stuff. So it's more like a traditional database. It's just to make people, I mean, to simplify the how to lower the I think we're just trying to make it easy to use, too easy to develop. So people don't need to focus on the underlying details for what kind of algorithm I need to choose for this vector search.
Do I need to tell which feature or which parameter, what kind of input to take for similarity, or Milvus will decide by itself to calculate the similarity?
So basically, currently for like a dense vector, so all the fields will be put together to calculate the similarity. But the way you calculate the similarity, it depends on what kind of uh, model you are using. So a lot of computer vision model, they are using like the dot product similarity matrix. So you can specify these this collection of vectors. You need to use Euclidean distance. That collection you need to use dot product. So Milvus will take care of all the underlying work.
But at the same time, it will use all the data in the vector to calculate that similarity. Is that so?
Yes, yes, all the
Okay.
vector data, because we are also trying to support the Scala data. The Scala
Mm.
data is outside of the vector. It's just like you add some attributes or labels to each vectors. So when you calculate the similarity, it only consider about the vector part, but you can do some filtering based on those Scala data.
Interesting, interesting. I just wanted to ask you, you were also mentioning about dynamic data type. So yeah, so dynamic data type, you did talk about it. You told us in one of the slides that you support dynamic data type. So what happens if when I want to add a data type or want to change a data type? Do I need to create this object storage all over again, or do I need to delete the existing vectors and recreate it again? Could you tell us what happens when you dynamically change the data type or introduce a new data type?
Oh, I'm sorry. So maybe I'm not clear. I mean, for the dynamic data management, when I'm talking about that, it's more like a streaming scenario, because you maybe have, for example, here, this user, they have 55 million trademark images, but maybe they're streaming like incrementally. They will have, for example, 5,000 images. They can be injection into the collection. That is what I'm trying to talk about, the dynamic data management for those streaming scenario. because by these vectors, the data type is more like, for example, you have a vector like 128 dimension, and each dimension is actually, for example, a float number. It's a float. So for a vector, the data type is more like the dimension will impact the type.
So yeah, I understand. So let me ask you this: is there any case where you need to remake this object storage at all? Do you? I think the case where my data source corpus itself changes. In such case, do you have to remake the vector storage at all, or there is no such case? I'm trying to understand.
Oh yeah, there's one case you will need to remake all these vector storage. This case is when you change your model. For example, you use VGG model to process all these images, and suddenly you just think it's not well tuned for your scenario, and you make some little more change. And in that case, the vectors need to be regenerated all over again. So you need to go through all these process again.
Thank you. Yeah, that makes sense. What are the current features under development? So you were from your description, it looks like a very active project, and I attended your talk in LFAI TAC as well, introducing Milvus. I think it was another excellent talk by you. And it is very clear that it is an active project which is undergoing a lot of good and exciting development. So can I ask you, what is going on? I mean, what is the current work which is going on, and could you tell us what would happen in near future? What are the exciting things which are coming?
Yeah, so currently at this release, we are trying to make this attribute support to support the Scala data. This is a big change because it will impact the way you store this data format in those data file, and how you manage this data. So, and also because there are different type of indexes, vector indexes. Some of them are using the clustering algorithm, some of are graphing algorithm, some of the index with compression, and some just flat index. So all these different type of things, we need to handle those different cases very carefully. So this is a big thing for us to support the attributes here. And also we are trying to further explore this the Milvus, the use case of Milvus to different scenarios, like a recommender system. So in that area, people use these kind of multi-model a lot. For example, a user may have different behavior in different app. So some kind of the internet service provider, they will collect all these different things, but they will try to form a unified user behavior pattern. But absolutely, you will have different behavior in different app. So that is a very normal, very typical scenario of this kind of multi-model or dimension collection, this kind of thing. We are trying to design and to support this kind of scenarios.
Very interesting. My next question, which I have, is about metadata. In one of the slides, you did talk about metadata. I want to ask you, yes, this one. So I want to ask you two questions. What do you mean by metadata here? And secondly, how important for you is the type of data that you are handling and its importance? Um, how important is for you or me if I use Milvus, how
Mm-hmm.
important it is for me to understand what is the characteristic of the data that I am dealing with, because I may be using a text corpus. If I am using a NLP based application, I may be dealing with frames. If I am using video, if I am using images, it is pixels. So something like that, right? It is very different types of data, and each of them has different set of characteristics
Mm-hmm.
of the data. Could you tell us a little bit more about this metadata and how important it is for me as a user to understand what type of data I am?
Okay. So metadata here is the same concept. In if you think about the database, you have the catalog tables to record all these database objects. What is the data file name, and what is the attributes for this database object, for example, how many dimension, and if there is any attributes attached to these vectors. So all these kind of information is metadata. So in Milvus, because if we're talking about like something like a SQL database like MySQL, they will store these kind of metadata or catalog tables into within the MySQL database, because they're already providing this kind of functionality. But for Milvus, because we're not handling these kind of information, so we employ components like SQLite. If you want a very simple deployment, you can use SQLite. We use SQLite to store the metadata. But if you're using a more a big environment, so you want to support a lot of objects into Milvus, then we support users to use MySQL to store these metadata. And also we're trying to support etcd in the future, so that people can deploy Milvus into the cloud more easily. For the second question, I think when users start to use Milvus, they need to consider several things. The first question is, what is the recall? What is the recall accuracy they need? Because if we want 100% accurate recall, you need this kind of index with this kind of search parameter. If you want 80% accurate recall, then probably you can use a lower cost index, and with a different search parameter, which will be much faster and lower CPU consumption. So this kind of question is the user first need to think about. And the second one is because we, in order to support these streaming scenario, we need to cut the data into smaller slides or shards. So there is a trade-off between the each data slice and the search performance. So if the data slice is bigger, then the performance will be better, but it will take more time to cut over a new slice. So the user need to think about how often they get all these new data. And also the data distribution also matters. If, I mean, because the so when you use Milvus to build up the prototype, you will run some performance tests. So you select one index and this kind of search parameter, you got a search performance. But if the data distribution in the future will be very different from these tests, what to run in the test, then the performance in the real production might be quite different from the performance tests over those prototype. So I think these are the three things or three questions users need to think about before, I mean, when they are trying to build up AI applications on Milvus.
Very good. Very good. Yes. Yes. Thank you. Thank you so much. I want to maybe a follow-up question. Suppose I forgot about an attribute. So you know, while I did the prototype, I forgot about a particular attribute, but now I want to add it. What sort of rework is required in my prototype using Milvus to add this new attribute? Could you please tell us about it?
Oh, yeah. Yeah, this is a good question. So at the first implementation, the attribute was attached to the vector when they first inserted into Milvus. So we are also thinking about how to, I mean, like alter you in the SQL table to edit one column, but in Milvus we still think about how to make it easier for this kind of alter a collection in a later time. So this is something we need to think about. But at this moment, it's just the attribute goes to the attached to the vector when you first insert into Milvus.
Now I have two questions. One about your GitHub, which I will ask later. But first, let me ask you about the timeline. So I am starting with the project now. Okay, I have let us say a natural language processing corpus which I want to now analyze and let us say make a correction or prediction or analysis inference based on my logging data because in our domain it is basically logging data which I would process to find out what is the root cause or make some predictions based on it, right? So yeah. I have a logging data which is basically unstructured data that I would like to now analyze. Now, could you tell us how long should I take in typically using this kind of the approach that you mentioned? Would that be a few hours, or would that be a few days? Would that be a few weeks or a month or so? How long does it take for me to build this kind of a pipeline as a project engineer, giving the estimate? You know how difficult that is. So could you tell us how I should do this kind of estimation with Milvus on my side?
Okay, so just like I showed before, like for example, this kind of stuff, like so your application will have several components. So there is a model thing. You first need a model, right? And then you need to work out a way to manage all these feature embedding vectors generated from the models. So Milvus will help you to minimize the time you have to work on these data related projects or components. You only need to focus on your model. Once you have this model, then you are ready to build up a prototype.
So how long does it take? I mean, for me to typically, if I use, let us say, if I just consider an NLP, in your experience, let us take your experience, what is your guidance?
It will be hard to estimate because I mean there are very good NLP models, pre-trained models for general purpose. But in your case, it's very specified. It's a domain knowledge. So you will, I think you very likely will have, you will have to spend some time um, tune these pre-trained NLP models so that they can be suitable for your scenario. So that's really hard to estimate, but I think that may take months.
Interesting. Yes, yes. Thank you. Thank you so much for that. And suppose if I have the model, how long does it take for me to create the vector database and use Milvus along with it?
Still this example. This guy actually spent around 5 working days to go through all the Milvus documents, and he made his first prototype, and I mean he got to make it work. So
that's pretty good.
yeah.
That's pretty good. Yeah. Okay, I want to ask you about yes, GitHub as well as the dependency for installation of Milvus. Can I install it in my laptop, or do I need a specific hardware? Because I see in your previous slides something about GPU, something about RISC-V, something about specific hardware. So I'm a little worried. So could you tell me, tell us what is the installation dependencies? Can I install it in my laptop? And maybe how much memory, how much CPU, how much whatever other dependencies that you have.
Okay, yeah, that's a good question. I mean, so we at this moment, the Milvus project provides two pre-compiled the Docker image. One is for the x86 platform. You only need an x86 CPU. You don't need any GPU. Another Docker image is to support the 86 CPU plus the GPU, the NVIDIA GPU. So for a laptop, as long as you have a x86 CPU, then you will be able to run Milvus. We support a old type of CPU which only has instruction sets like SSE 4.2. If you only have SSE 4.2, it's also you also can run Milvus on that processor. So about how much memory and how many disk spaces you need, it really depends on the data volume, how much data you have. You can, in order to get the best performance, you can cache all the data into memory. So then in that case, the search speed is pretty fast. But if you don't have enough memory, Milvus can also swap in and swap out the data. So it depends. If you have a lot of data and you want search very fast, then you need adequate memory to hold all these data. But if you don't care about the real-time search speed, you just want to have a reduce the memory cost, then you can also have a very small memory machine to run Milvus. It's also doable.
Okay, that is very good. And in terms of contributions to the GitHub, could you tell us the best way to contribute to this project?
Okay, so we are trying to create the community and with a all contributor model. So besides, I mean, when we talk about GitHub, it's most focused on the code, the source code or the project documentation. So all that kind of contribution is welcomed. If you want to contribute to code or project documentation, you can join our Slack channel. Our Slack channel, you can find our link on our GitHub repo. There's a join Slack link, and there's a channel in the Slack called the Milvus Dev. So if you want to contribute to code, and you can join that channel and to talk to our current contributor, the Milvus contributor, and to understand how to what kind of function we are currently developing and how you can participate within it. And also besides code and project documentation, we are also welcome people to, like, if you have some if you use Milvus, and you can write some blog post to introduce Milvus to more people. They're also welcome. We are also trying to track all these kind of contribution. I mean, we're welcome for the contributions in any way to make Milvus more known by more people.
Thank you so much. Thank you for answering all the questions very patiently. As I said before, I had the pleasure of attending your presentation to LFAI, and I keep track of the developments there. It is quite interesting project. Actually, Milvus is a quite interesting project. Thank you so much for agreeing to come and talk to us. I hope the participants and the viewers of the recording will find it as exciting. And thank you again.